The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, good evening, folks. We're going to get started here in about 5 minutes. We've got 10:55 here local time at 7 Signal headquarters in Cleveland, Ohio. I'd love to hear where you early birds are logging in from. I know I see some Russian characters in the attendee list, so I know some folks are far away, and we love having you guys, and we appreciate the fact that your workday is, if not over, almost over. So we love the fact that you guys are joining us today. So if you don't mind using the question and answer tab within GoToWebinar and let us know where you're logging in from. All right, we got South Africa, welcome. Roger, San Diego with Bill, thank you. We've got another California. We've got PA, Orfield. I'm not familiar where Orfield is. Is that on the east side or the west side of the state? So are you a Philly, an Eagles fan, or a Pittsburgh Steelers fan? That's what I'm most curious about since I'm from Philadelphia myself. We've got Montana, Des Moines, Iowa, Boston, UK, excuse me, Richie. That was on the east side. Okay, thanks, Paul. Florida, Iowa, another Iowa. So wonderful. Thanks, guys and girls, for joining us today. I've got Eric Camulli with me today. We'll do formal introductions in a few minutes, but Eric is working from home like I am, or well, I think he's on the south side of Cleveland. I'm on the west side of Cleveland. But good morning to you, Eric.
Hey, how are you, Don? Nice to hear your lovely voice on this fine morning. How are you?
It's good to be heard. I'm doing well. So this is I look at these things each week as like our distraction, and hopefully our audience feels the same way. You know, we got no sports, we've got no restaurants and bars to go to. So this is hopefully a welcome change from the day-to-day grind that has so significantly changed all of our lives so far.
I know. I agree wholeheartedly. I mean, unfortunately for our audience, we're neither interesting, funny, or witty.
I know. It's going to be a major disappointment for them from a comedic standpoint, but I think we'll make it up for it with content.
Well, that would be the goal. Okay, we'll do that.
So for those of you just logging in here, we're going to get started in about 2 minutes or so. We've got 11:58 here local time. We're just chatting a little bit, getting the conversation going, and folks are using the question panel to let us know where they're logging in from. Let me speed back through here again, see if we've got any additions. We got some more Florida folks. We've got some New York folks, more from the UK. We've got Russia. We've got Corpus Christi, Texas with an exclamation point. All those Texas guys are the same. We've got Mexico on board, Ireland. Welcome, everybody. Thanks for coming. We're going to get going here in another San Diego. We got Montreal. Thanks, folks. We got about a minute or so here, Eric, and then we'll kick things off. Very, very exciting. Everyone's chomping at the bit, waiting for us to go.
Yeah, we got a real motley crew here.
We do. Folks from all over. I think, what do you think? We got Delaware here as well, another San Diego. We got a contingency from San Diego coming in today. So who's going to get the part? We got India in as well.
Well, if you're going to come in from anywhere, San Diego's a nice place.
It is indeed. All right, well, I've got 11 o'clock on my computer, so why don't we go ahead and get started. Welcome, folks. My name is Don Cook. I'm the Chief Marketing Officer at 7 Signal. With me today is Mr. Eric Camulli, our Chief Customer Success Officer. Eric, welcome.
Hello, Don. Yes, Chief. How are you?
Right, thanks for that. So we've got a great webinar for you all today. If you haven't been a part of this webinar series in the past, we do host these every week on different topics. We repeat some of them because they are so extremely popular. This one in particular is our number one webinar topic that we continue to do on a quarterly basis. It's our basic Wi-Fi 101. We're going to talk through basic elements. We're going to talk through myths. We're going to talk through troubleshooting, and we're going to make it specific to both enterprise Wi-Fi and home Wi-Fi because of the environment that we're all in, right? There are a lot of us, depending on the industry that you're in, that are still going strong. If you're in manufacturing, if you're in distribution, if you're in grocery and some retail, you're still working in the office. You still got your day-to-day roles and responsibilities. And for a lot of us, everything is expanded to remote and home Wi-Fi, and we want to help you guys there as well. So Eric's going to help me with this today and run the show. I've got a couple things I'm going to walk through, a general overview for company stuff, and then we're going to get to the exciting stuff with Eric. So just a few quick updates. We're not going to go into our product demo today. Today is about you. Today is about giving you information, actionable information you can use to troubleshoot Wi-Fi issues for your remote workers and your enterprise workers. So if you do want to see a product tour, you can go to this URL, and I'll drop it in the chat room. It's go.7signal.com/tour, and we'll get you to the right place so you can see the product information specific to your needs. We are going to share a copy of today's recording. We'll give you access to the webinar slides as well, so stay tuned for those. No need to ask for those in the chat room because we will definitely share that. We do have a new case study in our knowledge base, our Florida Blue Cross Blue Shield case study. It's been very popular. Simply go to our website and click on knowledge base and expand the case study tab. You can get access to everything. All of our old webinars and the one from today will all be on YouTube. Our inventory there continues to grow. So if you want to access anything, any archive stuff or peruse through those webinars, you can certainly do that. And we've got two offers that we're going to walk through. So we've got two offers going on right now to help folks with troubleshooting remote workers. This is for our Mobile Eye product, and I'm going to get into the products here in a second. So if you're already confused, help is on the way. But go.7signal.com/50 for 50 will get you access if you are a prospect, if you're not a customer. So 50 licenses for 50 days to help you troubleshoot remote workers. And then our customers have a special one if you are a Sapphire Eye customer and not a Mobile Eye customer. It's the same URL except 1,000 for 60. We're giving customers 1,000 licenses of Mobile Eye to help them combat this situation as well. So I'm going to get into
generous,
the products.
Don.
Yeah, we're nice guys over here. We're doing our part to show that we're in this together. So, and I'll drop those URLs in the chat room as well, so you guys don't have to write those down. So a little bit about 7Signal for those of you who are not familiar, or maybe this is the first time you're joining us, but 7Signal's been around since 2007, and we're crunching a lot of numbers over here. We hit the 1 billion milestone mark last year. We're monitoring over 7 million devices on a daily basis, leads the industry. We've got over 200 customers around the world, over 30 partners. 13 patents. You guys are going to get a little news flash here. We're going to announce another one this week as well. So we'll be hitting the 14 patent number. Yes, very exciting stuff around roaming. So stay tuned for a press release near you. We're certified in over 40 countries around the world. We're GDPR compliant. So not only do we stay up to date with our technology stack, we care about data and data security and your end users as well. So we continue to stay focused on that. So in a nutshell, 7Signal is here to enable the wireless world. And what we're doing is we're finding and fixing Wi-Fi issues for our customers. So since 2007, we created a complete outside-in enterprise framework. We're the only company out there with this methodology, and I'm going to talk about inside-out versus outside-in a second. But all of our architecture is completely AP and device agnostic, all modular, depending on what your needs are from a services or product perspective. We'll be able to have a custom fit solution for you. All of our products are replete with reporting, alerts, and analytics, and let our customers be proactive with their Wi-Fi performance. And what we're doing is we're looking for the top 7 Wi-Fi problems with our software. And of course, these issues don't bubble up like this for the end user. Everything starts with, oh, my Wi-Fi is slow or I can't connect. But there are underlying causes or root causes of these issues: congestion, coverage, co-channel and radio interference, network services, roaming, adapters and drivers, and wireless LAN configuration. That's what we're looking for on the network with our software. And how we're doing it is we're running active and passive tests on the network and on the devices from the outside in, looking for things like throughput, packet loss, latency and jitter, a MOS score for VoIP quality, adapter and driver combinations, frequency and channel interference, and a full spectrum analysis, really giving you unparalleled insight into a network visibility you just can't get from your vendors, which I'll talk about here. So legacy versus outside in. So I said 7 Signals on the outside inside, excuse me, the outside inside of things. And what folks who are not 7 Signal customers understand the legacy side. You're depending on your access point provider, your device provider for information on whether or not the device or network are working properly. And that's all well and good. There's great information you can get from Cisco, from Aruba, from Zebra devices, from SpectraLink. They all give you great information, but they're not giving you the end user experience. That's where 7 Signal comes in. We live on the edge of the network, getting you the information you need to get to the root cause analysis quickly, going back in time so you're able to look at a specific time when an issue happened, whether you're servicing a help desk call or being proactive, getting alerted from our system. All these solutions we have for you that allow you to be proactive and get real visibility into your network. And we do that with 2 modules here at 7 Signal. We've got Mobileye on the left, Sapphire Eye on the right. Mobileye is the solution that we're promoting. You saw those promotional slides earlier on. That's for this product. This is the product that runs on the device itself. Any Windows, Mac, or Android device, completely 100% software based. Looking for problems like adapter and driver issues, roaming issues, co-channel and adjacent channel interference, coverage, and congestion. And Sapphire Eye is an enterprise solution. It's software-enabled hardware, a perfect client that installs up in the rafters with your access points or down on a tabletop at the device level, looking for things like network service issues, wireless LAN configuration issues, radio and co-channel interference, and coverage and congestion. So definite differentiation on the 2 solutions. Again, customizing based on your needs. So not all customers need both solutions, and a lot of times it's one versus the other. But we're the only vendor in the market that offers these solutions. Everything is reportable in the cloud through dashboards, giving you analytics and alerts and all that fun stuff you need to be proactive with your network. So thanks for listening through that. We're going to get to Eric's content now and talk through Wi-Fi 101 and give you everything you needed to know, everything you've ever wanted to know about troubleshooting Wi-Fi.
Well, thank you very much, Don. Don, correct me if I'm wrong, but did you say just a couple of minutes ago that 7 Signal is living on the edge?
We are living on the edge, Eric.
Wow, that is actually very exciting. Thank you very much for
that. More now than ever before.
You got that right. All right, well, let's jump into it. Today, our goal is to unlock the mystery of Wi-Fi. You know, Wi-Fi is, it's radio waves. You can't see it. It's in the air, but it's kind of invisible. So it can be rather frustrating for people. And what we promise to do today is to unlock the mystery of Wi-Fi. It's not magic in any way, shape, or form. You may already be familiar with Wi-Fi listening to us today, and if you are, then maybe you learn a couple of things about how to explain how Wi-Fi works to other people. I know that with a lot of people working from home, this is a challenge. People will call in and say, can you help me with my Wi-Fi? I'm having a hard time getting my work done. And if you, as an IT professional, are able to explain some of these basic principles to them in a way that they can understand, then boy, I'll tell you, I mean, we'll just clear the air literally and figuratively and get more work done. So let's dive into it. So just like Don was alluding to a moment ago, a lot of people will call in, they will complain just because they're connected to the Wi-Fi network. They'll blame it for everything, right, Don? Just unbelievable.
Yeah, they
And
do indeed.
so the point is that it's not necessarily a Wi-Fi problem just because somebody is complaining about it. And what we're going to endeavor to talk about today are these 4 areas. We're going to talk about how indeed it could be, in fact, your client device, your laptop could be the problem. It could be something in the air, just like we were talking about a moment ago, of course, that's causing the problem. After all, the air is the medium which the radio waves travel across. And next, we're going to talk about access points and how they could be the issue as well. And we just need to understand and know when, where, how, and why. And then finally, it could be the back-end network. And so this could be your backbone if you are working in an enterprise. If you are working at home, then it could be your internet service provider, and it's important to be able to understand that it could be their problem as well. Now, hopefully by the end of our presentation today, everything that is blank on the screen, we will have filled in for you, and you will understand. We're going to talk about those root causes. We're going to talk about the what to do by the time we get to the end of our presentation today. Let's start at the beginning, shall we? The medium that Wi-Fi uses is the air. Remember, I said it's radio waves, and these radio waves, just like when you tune into the dial and you listen to your favorite radio station, like 100.7, the Buzzard here in Cleveland, Ohio, and you want to listen to your classic rock and roll, okay, that is a licensed frequency, all right, a licensed frequency. You're not allowed to broadcast on that frequency, all right, and that's what we mean when we say licensed bands of spectrum in the air. Okay, but then there are also unlicensed bands of spectrum. Unlicensed bands of spectrum are basically free for everybody in the public world to use. And those unlicensed bands of spectrum include these 2 right here, 2.4 gigahertz and the 5 gigahertz band. And this is where Wi-Fi resides. Okay, now just like what I said a moment ago, you're not allowed to just broadcast and use any frequency that you want. You got to stay in the lines. Think about 2.4 and the 5 gigahertz band of air. Think of it as like 2 different highways. Okay, so Don, like when you travel to work in the morning, you're going to get on 480, right? 480, you're going to travel, which direction are you going? You're going 480 east, right?
Yeah, that's right. Yep.
All right, so then 480 east, and that's a highway. Now, and then, eventually you're going to start turning south towards corporate headquarters here in Independence, and you're going to get on what? You're going to get on Route 77, right?
Yes.
Okay, so that's another highway. And these are completely 2 different highways, and they've got different speed limits, and they've got different properties and everything. But here's the thing, Don. When you travel on the highway, are you allowed to drive on the shoulder?
I got to stay in my lane.
That's right. You can't drive on the shoulder. You got to stay on the road. You're not allowed to drive on the median and get around people if you want to. You got to stay on the road. And it's the same thing in Wi-Fi. There is a finite, limited amount of space, and we all have to play nicely on the road. If we don't, then we can get in trouble. Either the FCC will step in and say, hey, what do you think you're doing? You're not allowed to do that. You got to stay on the road. Or if you don't play nicely on the highway, let's say, you're like Don and you got your sports car and you're weaving in and out of traffic, okay? And if you're doing that, Don, that's going to be very disruptive to the other drivers around you, isn't it?
It would be if I had a sports car. That's probably true.
That's right. So what we're going to do is we're going to talk about how important it is to manage the air and how important it is to understand what's going on these 2 highways and how they interact differently or how they work differently. So let's get to it. All right, so you have to understand the differences between these 2 highways, these 2 bands. They're very different, especially with a lot of people working at home now. you really need to understand the difference between the lower frequency band, the 2.4, which is a lower frequency, as opposed to the 5 gigahertz, which is a higher frequency. Now, both of these frequencies, don't get me wrong, everybody, both these frequencies are way up in the stratosphere. I mean, it is just, like not even bats can, hear 2.4 and 5. Don, I don't know if you have hearing like a bat, but even you could not hear frequencies this high.
My wife does.
Oh, wow, that's fantastic. Wow, I got to hand it to her. All right, but the most important thing that you've got to know is that lower frequencies propagate farther than higher frequencies. Those higher frequencies are going to peter out a little bit more quickly. Now, granted, they can carry more data, but they don't go as far. So just like what you're seeing here, the 2.4 gigahertz spectrum is like that red sine wave that you're seeing right there. It's like a bigger sine wave, and it's it can kind of go up and down, and it can travel really far. And this is why these really super ultra low frequencies, like radio stations broadcasting on the other side of the world, you can hear them sometimes at night, because those big, huge, long sine waves can travel really far. Think of the blue sine wave on the screen as 5 gigahertz. It's a smaller sine wave. It kind of peters out a little bit more quickly. And this is really important to understand in Wi-Fi. Let's dig into it, shall we, Don?
Let's.
All right, so Don, you may be asking yourself, why does your radio cut out when you drive your awesome sports car under a bridge? Have you ever asked that question?
I have.
Okay, well, let's explain you the answer right here. It's because of barriers to propagation. Okay, so, and if you look at this beautiful sports car that Don drives right here, okay, you can see that it's underneath a concrete bridge. And concrete is one of those materials that radio waves just cannot get through. What's going to happen with concrete, you really got to be careful about this, is that radio waves are going to be absorbed by the concrete. They're not going to make it through. Okay, so this is really important. If you're living in a house or if you're living in an apartment building and they've got concrete walls separating the units, then that's great. Because now what that means is that your Wi-Fi signal is not going to go through the walls and potentially interfere with somebody next door to you. By the same token, if you live in Florida, okay, so I'm thinking about in Florida, all of those walls are made out of concrete block. And you can have your router in your house on one side of the wall in the office, and you can be in the living room trying to do some work, and you're, as the crow flies, 6 feet away from this thing, but you can't get good Wi-Fi. And it's because you've got these big, huge, thick concrete walls in your home. So people in Florida, I know you've got great weather, but this is just one of the detriments. Now, the other material that you really need to be careful of is metal. Okay, now radio waves are not going to be absorbed by the metal. Rather, it's going to reflect off the metal. So one of the things that we do is we look around. It's like, okay, are there a lot of metal surfaces in this area? Like a big metal filing cabinet or some metal shelving or something like that. And the reason why this is so important is because you might think that your signal is able to propagate, all the way down the hall. But if you've got some metal in the way, it's just going to bounce back. And so you need to be aware of your environment in order to ensure that you have a good Wi-Fi experience. Look around. Is there a lot of metal? Is there a lot of concrete? Or is it just glass and sheetrock and stuff like that and wood? Those are typically no problem at all. And the signal can propagate really nicely through those surfaces. So look around your environment and make sure what's going on, because it will play a part in your Wi-Fi experience.
Right, and for our help desk folks that are on the line today, maybe that's they build that into the questions that they ask the user on the other end of the phone.
Oh, that's outstanding. Yes, Don, I agree wholeheartedly. You need to understand your environment. You need to understand your surroundings. So let's put this into action a little bit. Let's pretend like this is an office or something. And we've got an access point in the middle of the floor, and it has 2 radios in it, and one of them is broadcasting on the 2.4 gigahertz band and the other on the 5. And so this blue circle in the middle represents the propagation, the cell size, if you will, of people or of the 5 gigahertz band. And then over here, the red represents the 2.4. As you can see, you can propagate much farther. So what I'm trying to show you here is that this guy right here in the middle of the screen, he's able to attach to the 5 gigahertz radio and get a certain experience. And then all of these guys out here on the edge, out here in the red circle, they're able to attach to the 2.4. Okay, they can't even, they're not within earshot of this blue circle, so they can't connect to the 5 gigahertz. They're too far away. The signal doesn't propagate far enough for them. And we'll talk about why that's important in just a second. Now, Don, I want to call your attention to this dude right here. Do you see this little guy?
I do.
So he's on the edge, okay? He's on the edge of 2.4 and 5. All right, now let me ask you a quick question. If he's on the edge like this, well, what's his device going to do? Is it going to grab the 2.4 network or is it going to grab the 5 network? Do you know?
Well, the device makes that decision. We don't know.
That's right. I don't know. You don't know. Nobody knows. Only the device knows. Okay, so it's the device. Inside your device, there's an adapter and it has software. And those software we call drivers. And it's that software driver adapter combination that actually is trying to make the best decision on your behalf. And I'm sorry to say, Don, but sometimes it makes a very poor decision. And sometimes it makes the right decision. But depending upon your device and its adapter driver combination, it will either make the right decision or the wrong decision, thereby putting your Wi-Fi experience in jeopardy.
Right. And for those of you who are curious about our products and software and where we can help here, this is where Mobileye comes in. So Mobileye on that laptop, on that SpectraLink handheld, on that Zebra device, on an IoT robot or others. So being able to see what's going on with that device and what decisions it's made, right, Eric?
Oh, absolutely. That's so true. Being able to track and trend the decisions that your device is making, and then using that information in order to intelligently inform you about, okay, what device, what adapter driver combinations make the most sense for my organization based upon the roaming behavior that I'm seeing, and then make recommendations accordingly. Now, remember what I said a moment ago. I was saying that, okay, we've got one radio here, or I'm sorry, one access point in the middle of the screen, and it has one radio broadcasting 2.4. It's got another radio broadcasting 5 gigahertz. But let's just say, for example, if I wanted everybody on the floor to be able to take advantage of the 5 gigahertz highway because I think it's a better highway. Well, in order to do that, you would have to add additional access points, okay, and create these little smaller cells with a little bit of overlap. And in doing so, then not only do you cover everybody in the organization, but then a person can roam nicely from one to the other and have a more and have a more continuous experience as they do that. And then what happens is that because of 2.4 and its ability to propagate, you know, you could be out here, Don, you know, enjoying lunch on the picnic table, all right, and you can still have some kind of a Wi-Fi experience as well. All right, so we kind of talked today about how 2.4 is kind of a lifeline network, and I'm going to tell you why in just a moment. Do you have a picnic table, Don?
We do, Eric, we do.
So let's talk about these highways one more time before we get into more differences between 2.4 and 5. Okay, so think about the highway analogy one more time. The highway is the band. There's a 2.4 gigahertz highway and there's a 5 gigahertz highway. Now on the highway, there are lanes, okay? And these lanes, again, you've got to stay in your lane. If you start weaving in and out of traffic, then you're gonna cause problems. And not only that, but when these lanes all fill up, it's like rush hour in the morning, although not this morning, but it's like normal rush hour where if there's just too many cars and not enough lanes, then things are going to slow down. And you know what? It's the same in Wi-Fi as well. We call that congestion, just like we call it when we're talking about, you know, the traffic jam. Now, one of the things that's really important to note, and if you take a close look at this picture, you'll see something really interesting. You see this lane right here? It's completely empty. Don, do you know why this lane is completely empty? Can you shed some light on this for us?
Well, in the US, that's an HOV lane, right? So you got to have a high occupancy vehicle to get into that one.
That's right. That's right. It's the high occupancy lane, the carpool lane, or sometimes called the diamond lane, as you can see right here. And it's completely blank. Look at that. Meanwhile, you've got all of these other drivers in these other lanes going really slow, all congested, trying to merge with the traffic over here on the right. I mean, this is just ridiculous how you have a perfectly good lane right here that nobody is allowed to use. Okay, that's the government for you. What can you say? Anyway, the point is that you really have to understand your channels, and you need to be able to plan properly. If you don't plan your channels properly, then you end up with a situation like this where you're squeezing everybody into just these two lanes here and preventing people from spreading out and using all of the lanes so that everybody can go fast and everybody can have a great experience. So let's take a look at that right now. On 2.4 on that highway, there's only 3 lanes. Okay, it's a 3-lane highway. And there's channels 1, 6, and 11. Those are the lanes that are available to you. Right now, of course, there's channels 2, 3, 4, and 5, but we don't use them in Wi-Fi. And the reason why is because they overlap. They overlap with 1 and 6. Okay, so if we're going to have a good Wi-Fi experience, you know, and take advantage, we want a 20 megahertz wide channel here in order to get the data rates that we want to achieve in order to have a good experience. We're going to use only channel 1, 6, and 11. Those are the only good usable channels available to you. Okay, overlapping channels is bad in Wi-Fi. So you think that you're being clever at home and you put your router on channel 7 or 8? No, don't do it. Stop. You're not only causing problems for yourself, but you're causing problems for others as well. It's like weaving in and out of lanes on traffic, Don. Cut it out, right?
Yep.
And so the point here is that with only 3 lanes available to you, okay, they get filled up pretty quickly. Remember, this is free spectrum. Anybody can get on the road. It's just like the highway. Anybody can get on the highway. And those lanes fill up pretty quickly. And again, if you start weaving in and out of traffic, that's going to cause people to tap the brakes, slow down, and it's the same thing in Wi-Fi. If these overlapping, it causes collisions in the air. Those collisions are going to lead to retries, and those retries are eventually going to lead to a stepping down or a slowing down of data rates, where now everybody's going slow. All right. So only 3 non-overlapping channels for 2.4, very low capacity. But check this out, Don. Help is on the way, because 5 gigahertz has over 20 non-overlapping channels. So this is like a 20-lane highway. So this gives everybody the opportunity to spread out and to go fast in their sports cars like what you have, Don. And everybody can have a really good experience. Now, there's some other cool things that you can do on 5 gigahertz as well. For instance, you can do channel bonding. When you do channel bonding, like over here, it says HT40. That means high throughput, 40 megahertz wide. You took 2 20s and you added them together, you got a 40. And this is like creating a super lane on your highway where you can go extra fast. As a matter of fact, if your device is capable, you can go double fast, twice as fast, which is amazing. And then over here, you've got VHT80, which, believe it or not, stands for very high throughput, 80 megahertz wide channel. This is where you're bonding 4 20 megahertz wide channels and creating one super wide 80 megahertz wide channel. Now, just because you have an 80 megahertz wide channel doesn't mean that you can go 4 times as fast. Okay, remember, it depends upon what's going on in the air. It depends upon your router, your access point, and it depends upon your device, just like what we were talking at the top of our presentation. Not only that, but when you create these really wide channels, it also raises the noise floor and it cuts down your signal to noise ratio dramatically. So it's very sensitive. And so you have to be careful about that as well. Here at 7 Signal, we rarely recommend people go to an 80 megahertz wide channel. Okay, not only does it cut down on the number of available channels to you. Okay, so wait, I went from 20 lanes, now I'm down to 18 lanes. Wait a minute here. Okay, so I mean, in some environments, you want all the channels that you can get. So we really don't recommend this because you're also increasing the likelihood that you're interfering with other people, that you're overlapping with other people around you, other Wi-Fi networks. But over here, a 40 megahertz wide channel plan is perfectly acceptable. And if in most offices, if you can do a 40 megahertz wide channel at home, if you can do a 40 megahertz wide channel, then you should be able to go plenty screaming fast with a 40 megahertz wide channel. Again, if your device is capable of it, of going that fast. All right, so Don, the next thing we're going to talk about is noise. Okay, do you like a lot of noise, Don?
I do not. I'm a quiet type of guy.
Yeah, I know the feeling. I'm kind of a quiet guy too. You know, passive as opposed to active, you know, more passive. Nevertheless, there is a lot of noise out there in the environment. We can't hear it. Bats can't even hear it. Remember, I was saying that these frequencies are just so high, but it's out there. And these devices hear each other, and that's the most important thing that you need to understand. So when we talk about noise, let's use this analogy. Imagine that you're sitting out on your picnic table, Don, and you're listening to your favorite song on the radio, and you're having a good time. Then all of a sudden, your neighbor on the one side of you comes out, and they start listening on their radio. And then the neighbor on the other side or behind you, they turn up their radio. And now when your wife, Erin, comes out and says, "Hey, I need your help," Don, you're like, "I can't hear you. What'd you say? And you know what, Don, that's only gonna go so far in your household before trouble starts. Am I correct?
Absolutely right.
Okay. So what happens is that it becomes this muddled mess like what you're seeing on the screen here, where nobody can hardly hear anything. Okay, nobody can hardly. So the person next door, they can't really hear very well. You can't hear very well, and it's just Erin can't hear very well, and so it's really a horrible experience. And we call this interference. This is what we mean when we say interference in the air. There's some kind of interference. So if an IT person says, "Well, I think you might be experiencing interference," it's like, well, what are they talking about? This is what they're talking about, where there's this other noise in the environment that's making it very difficult for you and your device to hear the transmissions from your router or access point, and vice versa.
Right,
Now,
and you can't, a normal person can't see this interference, correct? I mean, how are people finding this type of interference?
that's right. I mean, I don't care if you have X-ray goggles or ultraviolet light, or it doesn't. You're not going to be able to see it, Don. You're exactly correct. And so you need, special tools in order to pick up on what's going on in the air. You were talking about the spectrum analyzer. You were talking about other tools that are able to kind of hear these different signals and then report them out to you. These are obviously some of the things that 7 Signal can do for you. Okay, now, one of the temptations here, Don, that you might have, if you want to listen to your radio and your favorite song, is you might actually just turn up the volume. And because, you're a little perturbed, although I've never really seen you get too perturbed. You're a pretty easygoing guy, I'm happy to report.
I mean, if they were
Very
playing rap music, then you'd see me explode.
Oh, really? You're not a rap fan? What are you a fan of?
I like the classic rock, I guess.
Classic rock. Okay, got it. All right. So one of the temptations is to turn up the volume. And so people can do this in Wi-Fi also, where they can turn up the power on their router or access point. And in doing so, now your device, or you can hear the transmission going back and forth, or going forth, not necessarily back, because you really can't turn up the volume on your laptop computer. Okay, so that's it's really just shouting in one direction and not shouting back. We see a lot of this in environments, and there's like an unbalanced link where it's really great in one direction but horrible in the other. And many times it's because power is turned up way too high on the access point end, And it's just causing the problem that you're seeing right here, where now you're really being a jerk and disrupting your neighbor's experience on the left, your other neighbor's experience on the right. And like you said, you're an easygoing guy. I happen to agree with that. And so this is not really what you want to do. It actually causes a cascading effect where now other people are going to turn up their radios potentially, and it's just going to turn into a big, jumbled, muddy mess where nobody's going to have a good experience. And it's the same thing in Wi-Fi. What you want to do, Don, is you want to get to an environment like on 5 gigahertz where everybody can spread out and not everybody is screaming over top of one another. Everybody can spread out and just listen to their favorite song, okay? They can listen to their classic rock. If they want to, despite your wishes, they can listen to their rap music, and they can have a nice, quiet time enjoying themselves, okay?
Mm-hmm.
That's one of the reasons why we try to get people to move from the crowded, noisy 2.4 network where there's only 3 channels and everybody's screaming over top of one another, and we try to steer them to the 5 gigahertz network where they should be able to spread out and everybody can go fast, and just like what you're seeing right here. So if you're at home, there's a good chance that you're using 2.4. And if you're using 2.4, okay, then you may be susceptible to this Wi-Fi interference that we're talking about. It might be something like, imagine, Don, that you're living in an apartment building and you've got noisy neighbors beside you, you got noisy neighbors to the left of you, above you, below you, and just, but they're not making noise like, they're not drilling or playing the saxophone, but they're using their Wi-Fi network. And remember, we all share the air. So your Wi-Fi network could be interfering with my Wi-Fi network, could be interfering with their Wi-Fi network, could be interfering with her Wi-Fi network. And so that's where we really need to pay close attention, and we need tools in order to see where's all of the interference coming from, so that we can either do one of 2 things. With Wi-Fi, we either eliminate the interference in Wi-Fi, we can eliminate it by shutting it off. You can go knock on your neighbor's door, or you can walk across your yard and say, hey, knock it off, turn down your radio, cut it out. You ever do that, Don?
I do not. I like my neighbors.
Okay, good. Glad to hear it. Or the alternative is you can avoid the interference. If you're not going to knock on somebody's door and say, hey, cut it out, then you can avoid the interference altogether. And one of the ways that you would avoid the interference is maybe you take your radio and you'd walk around to the other side of your deck, or maybe go inside and you'd listen to it there in the comfort and privacy of your own living room. So when we compare the spectrum bands, okay, going 2.4 is like going into a noisy sports bar, okay, although, this is not something that you'd probably be doing right now. Nevertheless, when it's really loud and noisy and it's hard to hear the person next to you, that's like what 2.4 is. And you got to keep saying, hey, what did you say? Those are those retries, those retransmissions. And it leads to just a breakdown in communication. And the alternative is, hey, you know what? Let's steer our clients over to 5 gigahertz. Let's get them to change the channel, okay? And then you can have a nice, quiet, intimate time, you and Aaron enjoying dinner just like this, and just having a lovely time with one another, communicating properly and clearly, and hopefully effectively.
I'm Mr. Romance, as you know.
Indeed. All right, this is kind of an advanced topic I'm going to talk about right now. Okay, so this advanced topic is basically a feature that a lot of Wi-Fi networks have. Okay, you're probably not going to have this at home, but you would have it at the office. And it's called RRM, which stands for Radio Resource Management. Now, different vendors call it different things. Don't be alarmed about that. But the point is that you can't see it happening, but in an attempt to avoid the interference and all of the noise that we were just describing a moment ago, your access points are actually running these sophisticated algorithms in order to increase and decrease the size of the cells. to automatically change the channels in order to try to create the best possible experience. And you know what? Most of the time it does a good job, but sometimes it gets a little haywire and it does a bad job. And this could be your problem also. Sometimes situations like what you're seeing on the screen right now occur, where you've got 3 access points and they all kind of end up on the same channel, like this, channel 36. Now, Don, this is the equivalent of being like on 3 lanes on the highway, and then here come the orange cones, and now everybody's got to try to squeeze into 1 lane on the highway. Has that ever happened to you before?
It has.
Oh my gosh. Is that aggravating or what?
Yeah, very frustrating.
Yeah, very frustrating indeed. And so what we want to do is we want to be able to detect these situations so that we can avoid them once again. Okay. Now, the other thing that's really important to note is that when you go and look at your laptop computer, it has certain capabilities as well. And so you need to know what you're buying. And on the surface, these 2 laptops look like they're, about the same. One of them on the right has an i5 processor, the one on the left, i3. And so you might say to yourself, all things being equal, I'm going to go with the i5 processor. But unfortunately, you would be wrong. You would have made the wrong choice, Don, because the laptop computer on the right doesn't even have the ability to get onto a 5 gigahertz network. Can you believe that?
Now that would be a bad purchase.
Exactly. So that has a BGN adapter. What you need to look for is the letter A. Don't ever buy a laptop computer on Amazon or anywhere else unless you see the wireless with the letter A, like on the left, you see AC, or the new standard is AX, which is also called Wi-Fi 6, which is a new terminology. But if you see ABGN, you'd be okay. If you saw AGN, you'd be okay. If you saw AN, you'd be okay. But just, you've got to look for the letter A. That is our advice. Okay. So the Wi-Fi Alliance they are changing the nomenclature. So instead of 802.11ax, they're trying to make it easier, mostly for the consumer market, so that they can look at something and say, okay, Wi-Fi 6, that's the latest and greatest. Fantastic. But what does that mean? Okay, so Wi-Fi 6, not really designed, this latest standard, not really designed to increase speed, really more designed to increase efficiency. It's kind of a channel sharing technology or an airtime sharing technology. So when we have a lot of devices in the environment that have AX technology or Wi-Fi 6 technology in them, they'll be able to share the air between each other better with a Wi-Fi 6 access point. And if you're wondering what your capabilities of your device are, then you just do this. You open up a command prompt, you go and you open up a network shell, netsh, WLAN show interface, and you can actually see what kind of device you have, what kind of adapter you have. So mine, as you can see here, it says wireless AC. And then I look that up and I can see what its specifications are, okay? And now this is the other thing that you need to be careful of, not just your devices, but also your routers. Different routers have different capabilities, right? And so you see a router like this and you might think to yourself, okay, wow, this looks really mean, looks pretty scary, okay? Don't be afraid, Don. Looks pretty scary. It's not a hairy spider. Instead, it is a router. It's a tri-band router. Okay, and what does that mean? It means that this access point right here has 2 radios in it. One of them is dedicated to 5 gigahertz. The other one is a dual that can go back and forth between 2.4 and 5, 2.4 or 5. Okay, and the idea here is that you don't necessarily need to spend this kind of money on a router if your device is not capable of taking advantage of all of this, and most devices can't take advantage of how fast this thing is able to go. This thing says it can go 5,400 megabits per second. No laptop computer can go 5,400 megabits per second. They just can't achieve those data rates, so don't waste your money. Okay, so here we go. This is it, Don. Know what it takes to have a great Wi-Fi experience. All right. It could be your environment. It could be what's going on in the air. You could have noisy neighbors. They might not be playing nicely. They might not be sharing the air correctly. All right. So we need to see what's going on with that. It could be your device. Some devices aren't even capable of getting onto 5 gigahertz. Some devices are just, they only have a single stream. They only have one antenna in them. Other devices have 2 antennas, 3 antennas, thereby increasing the amount of data that they can transmit and receive. It could be your network, like your router or your access point or your backbone. And of course, it could be your ISP. So once you understand all of this, it becomes very easy to narrow it down. So here you go. This is it. We talked about these 4 areas, okay? And let me get all of this up on the screen here for you. I'm not going to go through it as our time is running down, but I just wanted to show you that once we're able to identify which of the 4 main problem areas it is, we're able to then go down the path, and then we are able to take action. And that's the most important thing, take action. The what to do is absolutely critical. And here at 7 Signal, you know, that's our business. You know, we're not only going to show you what's wrong, but we're going to help you understand what you need to do. Or, you know, we can even help you do it as well if you'd like. So Don, I think we've done it. I think that's the end of the road. And I'm going to hand it on back to you.
Yeah, thanks, Eric. I appreciate it. Well done, as usual. Love this Wi-Fi 101 topic. So at this point, let's get to your questions. I know we ran a little bit over on our time today. We try and keep these to 45 minutes, but I wanted to keep going because the content is just so good, and I know that I was getting a lot of questions coming through, and I want to be able to get to those. I did get some questions about a copy of the slides. Absolutely, we'll share a copy of the slides and the video with you all, so don't worry about that. So let me just get into the questions here, Eric. My first one here is, does 5 gigahertz have a smaller range than 2.4 gigahertz? From the screen, I saw blue that shows 5 gigahertz and red that shows 2.4.
Yeah, absolutely. So the higher frequencies, they can't travel as far as the low frequencies. So yeah, they can only reach so far. So in order to take advantage of 5 gigahertz, you need to be closer to your access point or closer to your router. Like for instance, in my house, when I am sitting in the office next to my router access point, I'm on 5 gigahertz. But when I go downstairs and I want to sit on the deck, I make sure that my computer switches over to 2.4 so that it can get a good, strong, a better signal. Otherwise, if I were to stay on 5 gigahertz out on my deck, it would be a very, very weak signal. And a weak signal, it's like having only 1 or 2 bars on your cell phone. It's going to lead to a lower, slower data rate and experience.
Thank you, Eric. A question on Mobileye here. Can Mobileye be installed on IT devices, robots, etc., outside of Windows, Mac, and Android? So I know we do have a solution for that with our mini PC. Eric, you want to talk about that a little bit?
Well, sure. Yeah, it is based upon the operating system. So just like what you said, it's going to work on any device that is a Windows, Mac OS, as well as an Android device. A lot of IoT devices are Android devices, so we'll work on those, whether that be like a SpectraLink or a Zebra phone. The other thing that we are working on that's on the roadmap is a Linux version of Mobileye, and that Linux version of Mobileye will coexist very nicely with a whole slew of new IoT devices that are out there today and that are coming down the pike. So that, I think, answers the question. I believe that answers the question, right?
Yeah, and we do have another option. We do have customers that have smart forklifts and robots and such that don't have a traditional operating system, certainly far less than an Android or Windows operating system, and they're using mini PCs where they're attaching a very cheap off-the-shelf Windows-based mini PC, installing Mobileye to that device, and then attaching the device to the forklift, to the robot, so they're able to get those coverage, adjacent and co-channel interference issues and troubleshoot that way. Am I right?
Oh yeah, absolutely. That's a really good point. We're going to be able to kind of identify the roaming behavior as that forklift or robot moves around a warehouse. We're going to be able to get a lot of really good information about, maybe where the dead spots are, or where there is potentially co-channel or adjacent channel Wi-Fi interference. So right on target there.
I'm getting a lot of feedback here around great presentation, so I just want to make sure you knew that, Eric, at least half a dozen here, so keep up the good work. Next question here is, how does channel bonding increase the noise floor?
Sure. Boy, I wish, I could go into all of the physics behind it, but basically every time you double the width of the channel, then you lose 3 dB of signal. It's just there's like physics involved in that. So to go from 20 to 40, that's 3 dB, and then to go to 80 megahertz, that's so what you're doing is you're basically like decreasing your signal to noise ratio dramatically. What that means is that if you're going to be using 80 megahertz wide channels, you better be really close to that access point, because I mean you're just like I said, it just because of the physics involved, it actually reduces the signal. So, not being a physicist myself, I can't go into. I mean, I did stay at a Holiday Inn last night, but I'm not a physicist by any means. So I'm just gonna kind of move on from that one.
Alrighty, good enough for me. Next one here. Thanks, guys. Great webinar. Question regarding non-overlapping channels in 5 gigahertz. You demonstrated how there were 24 channels, but apart from the lower 4 channels and the upper 20 channels or so, it tends to be DFS channels. I can
Sure.
also see my AP from time to time that it forces itself and the clients away from a channel. What disruption, if any, does this cause for clients?
Oh, wow. Okay. So yeah, so we have like the Uni 1 channels, which are all the way on the left, and we have the Uni 3, which are all the way on the right. And then in the middle there, we have the Uni 2 as well which are a few channels. And then we've got the DFS channels. The DFS channels are kind of also used by the government. They're also used by like weather radar. And when your access point detects, it's like some kind of a weather event, like a Doppler weather radar event, then what it does is it will actually kick your access point off that channel, and it'll make it change. It will make it change. Now, the repercussions of that is anytime your access point changes channel, and if there are clients connected to it, those people just got disconnected. Okay, they just got disconnected. And if they were, and then those DFS channels, because of the event that took place, when they are automatically kicked off, then they can't go back onto those channels for like 30 minutes. It's crazy. Now, if you are not near an airport, if you're not near a harbor, if you're not near a weather station, then you should. It's Seven Signals' recommendation to use the DFS channels if you can. Okay. If you don't have to concern yourself with these weather events that I'm talking about. There are a lot of channels in there that are perfectly good to use, and you should be using them. Now, by the same token, let's advance the story. If your controller is changing channels a lot, okay, that could be very problematic. It shouldn't be doing that. Maybe a little here and maybe a little there. But if your radio resource management software inside the controller is switching channels many times a day, that could be causing a very bad experience. What you need to do is you need to tighten up the settings in your RRM or your ARM controller. You need to tighten up those settings so that those channel changes are only taking place a little bit, maybe once or twice a day. If even necessary at all. It's like you don't necessarily have to change channels all the time. And again, if there's no reason why you should not be using those DFS channels in the middle, just so long as you're not near like an airport or a harbor or a weather station, in our opinion.
All right, time for a couple more questions here, and if we don't get to these questions, we can certainly get those answered offline as well. How do you troubleshoot a user's home network when they have range extenders installed?
Good old
We
range.
might not we may not be able to help them there, but
Yeah, sure. Well, first of all, I'll say, I mean, not all range extenders are alike. Some of them are half plex, some of them are full duplex. And that does make a difference, because what it has a tendency to do, if it's not a full duplex, is it'll cut your throughput in half, basically. So you do have to be careful about that. But if you're paying for 30 megabits of throughput into your house, and you're only getting 10 or 15, you should still be having a good experience. So that's no big deal. I think what you want to still be looking at, nevertheless, when troubleshooting is, especially with Mobileye, you can see the signal strength and the data rate that they're connecting at. Okay. Now they may think that their range extender is doing a great job, but it does cut some of them do cut the available throughput in half. Look at their signal strength. Make sure that it's a good, strong signal strength. You want it to be around -65 or better, or lower. -64, -63 is what I mean by that. As soon as you get into the 70s, especially if you want to be on 5 gigahertz, it's just not going to perform. 2.4 gigahertz, you can operate fine at like -70, -71, and still get a good data rate. But if you are troubleshooting somebody, look at that signal strength. Make sure that it's a good signal strength, -65 or better. Not only that, but you're going to want to look at their throughput. What are they achieving in terms of speed? If they've only got if they have a cheap extender, a crummy extender, it could potentially be cutting their throughput in half, and that could be the problem as well. You might want to look up the device model, if you will, and just see if it's a full duplex or not. So those are just some of the things that I can suggest.
oh, was I talking to myself there, Eric?
Yeah, it was totally dead air.
Oh, wonderful. That's great for radio. Guys, I was going to shut it down there. I've got some really long questions in here that require some long answers. I apologize for the muted line. But thanks for joining us today. I'm going to take all the rest of the questions offline and make sure engineers get to those. Join us at every Friday at noon. If you're interested in seeing a product tour, go.7signal.com/tour. And thank you very much for coming today, everybody.
Thank you. Have a great one.